Hi everyone, and welcome to the sixth webinar in the AWC3 webinar series about watercourse crossings. So my name is Daniel Monaco, and I'll be acting as host for today's webinar. Before we get things going, I just want to give you a brief introduction to AWC3, in case you haven't seen any of the other webinars in the series so far. So AWC3, Alberta Watercourse Crossing Collaborative, is a not-for-profit organization whose primary objective is to facilitate information transfer around the issue of watercourse crossings in Alberta and their impacts on native fish species. So that's what this whole webinar series is about, is sharing information from subject matter experts and trying to get that information out to as many people as possible. Since we have received some questions about this, I just want to let everybody know that the webinar can be used for continuing competency credits for professional associations. So it counts as a half hour of credits and has been approved by most major professional associations. So if that's something you're hoping to take advantage of, please keep your receipts and your registration confirmation email. And if you have any questions about this, you can email info@awccc.ca. And we can get back to you about that. So today's webinar is about drones and spatial software used in watercourse crossing planning. And we have Iain Sharp with us today as a presenter. So to give a bit of a background on him, so Iain is a recent graduate from the University of Alberta's Centre for Earth Observation Sciences Laboratory. During his studies, he was involved in projects ranging from validating multispectral satellite imagery data to flying drones to extract the amount of photosynthesis that occurred in tropical forests, and which even extended to the uses of terrestrial laser scanners to model both forests and engineered buildings, such as those found at Singapore's Gardens by the Bay. Since then, he has started working with Woodlands North as a restoration ecologist who has been using both drones and GIS software to help prioritize watercourse crossings for restoration and ensure that adequate data is acquired to successfully plan out those restoration projects. So before passing things off to Iain, if anybody has any questions throughout the presentation, you can submit those through the GoToWebinar program. So on the tool panel on your the right side of your screen, you should be able to submit questions. I will be compiling those questions throughout the presentation, and then we'll get to them in a Q&A portion once Iain is done presenting. So without further ado, I will pass things off to Iain.
Thank you, Daniel. And thank you all today for coming and seeing my webinar about the use of drones and spatial software for roadway watercourse crossing planning. I thought that it would be more interesting to start off with a video about a project that we did up in the Swan Hills region, where we used drones to actually take 3D point cloud imagery of the site itself. So we'll just dive straight into that, and we will, I'll talk about some of the aspects of what we see in that video afterwards. So. Okay. Um, so I apologize for the atrocious music. I thought it was better to listen to something than nothing at all. Um, but yeah, so before we go into some aspects of what that video entailed, I thought I would just do a brief overview of who I am. I know that Daniel already introduced me, but my name is Iain Sharp, and I am the restoration ecologist at Woodlands North. I've been working there for about a year now, using drones to help acquire information about roadway watercourse crossings and using GIS to help prioritize those crossings that need to be remediated. My background with drones started at the U of A, where I was using multispectral drone imagery to try and capture the amount of photosynthesis occurring in tropical forests. But I started to dabble with photogrammetry, where I was actually trying to recreate forest canopies using drone photogrammetry. And that's really the crux of what we're going to be talking about here today, is the use of drone photogrammetry and roadway watercourse crossings. So just so that we all are on the same page as to what photogrammetry is the science of essentially turning 2D images into a 3D model or a 3D point cloud. And what photogrammetry does is that essentially as your drone flies in a transect, it is going to be taking multiple pictures with some degree of overlap between each photograph. And the reason why we are taking photos with overlap is that we are trying to identify common tie points between images so that we can start using those images to stitch them together to form a bigger picture. So typically with when you're trying to create a 3D model, you will take photos of an area in one direction and then photos of that exact same area at a direction 90 degrees to the original orientation. And that just gives you multiple different angles of the same scene, which then you can use as to tie together to create that 3D point cloud or that 3D model. So the outline is going to go over essentially planning, what you need to consider when you do drone flights. And the planning stage is really the most crucial and important stage of the entire drone flight process, I think, because if you don't have a good plan in place of what you want to achieve, you're not going to get good results. You know, crap in, crap out, essentially. And so the planning aspect and knowing what you want to achieve with drone flights is really the most crucial part, because when you actually go to the flight itself, typically you're not the one doing the flying. The drone flies itself. So you knowing how to control the drone in the air isn't as crucial as the actual planning process itself. And then we'll also talk about some of the post-processing, what is available in terms of software, what can you get as outputs from it, and what services are provided by this post-processing software. So first, let's talk about the current drone types. Essentially, there are two different types of drones. There's the helicopter style, which most people think of when we talk about drones. And then there is the fixed wing or the airplane style. And so the helicopter style comes in different types. They're usually quadcopters, hexacopters, octocopters, and that's just how many props or blades are being used to support the drone. The advantages of a quadcopter drone are the same as the advantages of a helicopter. It is capable of hovering. It has more control in tighter space. You need less takeoff space for the drone itself. And these drones typically have a larger range of price availability as well. You can get drones that are anything from $100 to tens of thousands of dollars, depending on the payload requirements for that drone, what you want to put on it, and the type of energy source that the drone uses, because you can have anything from battery-powered quadcopters to gasoline-powered quadcopters, depending on what you need to put on that drone. When we talk about fixed wing drones, some of you might think of like the US military Predator drones. Those certainly apply, but the photo that we have here in the bottom right is an EB drone from SenseFly. And the advantages that fixed wing drones have is what the advantages of planes have over helicopters, is that they can cover more ground in less time. They can transport heavier payloads than your quadcopter can. They typically have longer flight times. A quadcopter is typically limited from anywhere from 10 minutes to 30 minutes, depending on the weather conditions, whereas a fixed wing drone can fly upwards of 2 hours on a single flight. And they're typically more durable, but the fixed wings also typically be a lot more expensive than your quadcopter or helicopter style drone. So we'll just go straight into the planning, and really with any good plan, we start out with goals and objectives. You need to have a very clear idea of what you want to achieve with a drone flight before you start doing anything with the flight itself, because you need to know the level of precision and accuracy you're looking to acquire from a drone imagery before you start to plan exactly what you're going to do with your flight plan. Um, and everything that you do in terms of adjusting the parameters of your flight plan has to come back to your goals and objectives, what you're trying to achieve, how much effort you want to put in, etc. The next would be to have a really good idea of what the site looks like that you're going to be working on. How homogeneous or heterogeneous is the environment that you're looking at? Because if you, let's take for example, you are looking at a very homogeneous environment such as a gravel pit. Well, when we talk about photogrammetry and seeing as it is trying to tie pictures together using common tie points, it is hard for the post-processing software to be able to identify one piece of gravel from another piece of gravel. So if you have a very homogeneous site, you might need to increase the amount of overlap that you're taking between photos or the amount of ground control points, etc. So having a really good idea of what the site looks like before you arrive or before you do the flight is necessary. And something else that we need to take into consideration is permissions and weather checks. So permissions, there's a lot of suspicion around drones, and people typically don't like it when you're flying a drone without permission. And so you need to ensure that you have permissions from all the site managers and from the company that you might be working for, especially if it's not your own company, before you go on site. And you should really, I always have my permissions printed out with me so that if anybody does approach me on site to ask me about why am I flying into this area, I can give them the paperwork and say such and such person gave me the authorization to fly this area. And weather checks are also really important. The perfect day to fly a drone would be a cloudy day, because then you can fly a drone all day without having to take into consideration shadows or shading, or the effect of the angle of the sun on your pictures. But you also need to check for things like how high are the wind speeds? Can my drone remain stable at these wind speeds, or am I going to have to wait for another day? Is it going to rain today, etc. Because drones, whilst they have advanced in the last 10 years, they are still quite limited by the environmental variables that they can actually operate within. So if I'm planning a flight, what am I going to use to plan that flight? Well, with the expansion of the drone industry has also come an expansion of services that are available and software packages that are available, as you can see here. And it can get really overwhelming to decide which one you should use. But essentially, we can break down flight planning software into two different categories. You have your drone manufacturers flight planning software, and then what I would call your data analytics software applications. So this would be, let's say I use Pix4D as my post-processing image software. Well, typically a company like Pix4D, because it does drone imagery post-processing, it is also going to have a drone flight planner. And the reason why I would use the Pix4D flight planner over my drone manufacturer's flight planner is because Pix4D has already taken into the effort to try and integrate the entire process for me. So if I use the Pix4D capture app to do my flight plan, as soon as my flight is done, the process is going to start to actually get that project imported into my Pix4D mapper software for the post processing aspect of it. So it's just all very streamlined for me. And that's what I would do personally. But why might I use flight planning software in the first place? Why don't I just fly the drone myself? Well, flight planning software is really useful in terms of both standardizing the process. As you can see here, when I am planning my flight, I can get the entire area that I want mapped out on a map. I can also set all of my parameters that I want. I can set my angle of the camera, the amount of overlap I'm taking in between pictures, and it's also very useful for experimentation, especially if you're new to the field of drones and drone flying. If you don't know exactly what is going to give you the best results for your application, uh, using the same flight pattern or the same area and just adjusting some of the settings is really useful. And you can do that in separate projects, and you can then look at the results and see, okay, I got this degree of precision with this flight plan. This is the one I want to use in the future for these applications. The other useful thing is that a lot of these have really integrated everything that you need to know about the flight plan before you even start the flight. So here on the right, you can probably see that you have your drone health conditions. So everything from your battery life to how many satellites are required to how much room you have on your micro SD. And then here on the left, you can see that you can actually determine your flight height, which is hard to do if you were to do it manually, but if you do it through the flight planner, you ensure that you are staking around 50 meters the entire flight so that your pixel resolution is going to stay standardized, and it will also help you know how long is your flight going to be. The other useful thing about using flight planning software is that the drone tracks its progress through the flight plan. So let's say you're covering a large area that is going to require multiple batteries to use with your drone. Your drone, once it gets to too low of a battery level through the flight, will actually stop the flight plan, come back to your home base, land in front of you. All you have to do is do a hot switch of the batteries, put in a fresh set of batteries, start up the drone again, re-upload the flight plan to the drone, and then tell it to resume. And it will take off, go back to exactly where it left off on the flight plan, and then start continuing its flight plan once again. So it is a lot easier to do larger missions using flight planning software, especially when they involve multiple batteries. So what are some considerations that you need to make with your flight plans? Well, the first should be, what is the amount of effort that you can afford to do for a single flight? And this really ties back to your goals and objectives, which is, how precise do I need my imagery? Do I need 2D imagery, 3D imagery? How many sites am I looking at doing in a day? And as we all know, time is equal to money. So I would say that for a roadway watercourse crossing, typically a flight might take 30 to 45 minutes, and that's from start to finish. Everything from getting the drone set up, setting up my ground control points, ensuring that the area is safe and clear, doing the actual flight, and then also the teardown of the entire process. But depending on the accuracy that you want or the precision that you need, it could take longer. If you're covering a large area, you might need multiple batteries. That's going to extend your flight or your time at one site from an hour to maybe 2 hours to maybe 3 hours. So that's something you need to consider before you start to fly. The next is, what resolution do you need your map at? Typically, if you increase the height that you're flying at, you are decreasing the pixel resolution that you're going to acquire from your drone image, but you're also decreasing your flight time in total. So it's really a trade-off, and this ties back to our goals and objectives. What level of precision am I looking for, and what am I looking to achieve out of a day of flying? We also have to start to consider things like, what is the area that you are covering? So am I only interested in the roadway watercourse crossing itself, or do I need to capture more context of what is around the roadway watercourse crossing, either upstream or downstream of the roadway watercourse crossing, or even along the road? Do I know that I'm going to need to see where I can stage materials and the such? So to that degree, also, what do you need for overlap? So overlap can be broken down into both front overlap. So as your drone flies along a transect, it will take images, and how much overlap do you need along that transect for images? And then sideways overlap. So how much overlap do you need between transects as your drone flies? And so that'll determine both your flight time, probably your time at site, and the precision. So this all ties back to what are my goals for this flight. Another consideration for this is what is the precision you do need for your measurements, and what is the type of environment that I'm looking at? Excuse me. So for example, if I am flying a gravel pit and it is a very homogeneous environment, I'm probably going to need more ground control points. So what are ground control points? Ground control points, if you can see in this image on the right, are those checkered black and white squares. And all that is a ground control point is something that is heterogeneous against the background environment, and that is static in nature. So, and that's really important, because if your ground control point isn't static, let's say you have ground control points and the wind moves one of them from position to position. Well, if that's the only tie point that two images have with one another, and that ground control point has moved between those two images, when the post-processing software stitches together those images, it's going to warp and distort the area, which is going to decrease the precision and accuracy that you have for that area. So that's something you need to consider. And the more homogeneous an environment is, the more ground control points you're going to need, which also contributes to sight time. How much sight time are you going to need there? Something else to consider is what type of GPS do you need? Are you comfortable with the manufacturer's integrated GPS unit that is within the drone? Or do you need something with higher precision, like an RTK GPS that can give you millimeter accuracy? And then last but not least, what are you looking for outputs from the drone imagery? Are you looking for just 2D imagery, or do you need the 3D point cloud itself? And this is important to note before you get to site, because you have to change your flight plans and your flight design depending on what you're trying to capture here. You know, a 2D, if you're only trying to get an ortho image or a 2D image from this, you just essentially have to fly a single grid pattern over the area of your interest. But if you're trying to get 3D imagery, you essentially have to fly that original grid and then another grid that is 90 degrees to that orientation, and that is going to double your flight time, and it's also going to increase your sight time there, and the amount of variability that can occur in both environmental conditions during that period can increase as well. So depending on the time of day you're flying, you know, shadows could get worse, et cetera, et cetera. So you need to just consider, what do I need? Do I need 2D imagery, 3D imagery? What is it? So what can we actually achieve? What can we actually achieve here with the flights? Well, if we go back to that original video, what we see here is essentially the oblique angle of that road. And what I see here is, okay, we captured more area than the actual roadway watercourse crossing itself, so that we would have a better idea of what we're doing. So I could use the drone imagery here to extract the elevation profile from the drone. So here we saw that, hey, the slope on the north side of the road is less steep than on the south side of the road. So we should be using the area on the north side as our staging area to put all of our materials, because it is a lot less likely that we're going to have a washout go into the river that we're trying to repair here. Another is to actually have a lot higher degree of precision of knowing where your culvert is and how deep it is in the ground. So if I'm here and I'm trying to excavate this culvert, I could actually extract the volume of earth that is probably above it, but I can also look at the culvert in relation to the 3D environment in which it is interacting with. How far above the ground is it on the outlet side here? What is the gap between the outlet side and the pool itself, et cetera, et cetera. And it's also useful for looking at utilities placements. So here we can see that there's a couple of telephone poles, and if you actually look at the 2D imagery of the of this site, you can see the telephone or the power lines themselves going across the site. So you could look, oh, we can see that the power lines here are crossing over the culvert. This is something that we have to consider when we are doing the excavation process, how we're going to accommodate for that, what do we need to be aware of here. And it's also really useful if you have an idea already of where your utilities lines might lie, that you could overlay that on top of this 2D or 3D imagery and have an idea, okay, this is another problem that we're going to encounter when we're using the utilities. Some other things that you could use the drone flight for is, and the 3D imagery in particular, is getting volume estimates for construction. So you could actually look at the amount of volume that I'm going to have to excavate to get this culvert out. And that can help you in getting a better estimate of your timelines. So you could say, okay, I know I have X amount of cubic meters that I need to move. My excavator can do so many cubic meters per day. And I have a lot better idea of what the timeline would be for my excavator to do that. It also helps me understand how much materials I'm going to have to buy or purchase to either backfill into that new roadway watercourse crossing, or how much material I'm going to have to transport out of that area as well. Another use for it would be to provide ortho imagery that can be used in engineering designs. So here in the bottom right, this is our design for what a watercourse crossing might look like, or a remediated river might look like. But you could also use this ortho imagery if you need to tender contracts out to engineering companies and they need to have a better idea of what the site conditions are. A drone's ortho imagery is going to give them the best idea of what they're actually looking at in terms of the site conditions and the watercourse crossing conditions as well. So drones aren't just limited to the planning stage. They're also good for during construction. So here we see a time series of that exact same watercourse. And what this is really useful for is that if you're a manager, a site manager, or a superintendent, and you're not able to get to site, but you want to see an update of what your site looks like and what the progress is, well, you can have somebody on site just quickly put up a drone, fly it, take a couple pictures, and then download those images and send them off to you within probably about half an hour, 45 minutes at the very most. And so you, as a superintendent, instead of having to drive several hours to the site, have an idea of what is going on, what type of progress is being made, and it also gives you a different perspective about maybe you can see problems that are arising that you couldn't see if you were just on the ground before they start to get exacerbated. For example, you could see that possibly, oh, I see that there seems to be an oil sheen on the water surface to the south of our crossing. Have we accidentally uncovered an oil spill per se? And you can get on top of that quicker than maybe the people on the ground can see this happening. So that's another use for it. The other use is to do up-to-date materials inventory. So as you're excavating or using up materials, you can have a person on site quickly fly around the materials, get a 3D image or 3D model of that pile. And so you can have a lot more up-to-date and accurate information about what materials are on site. Is it worth me actually transporting these materials off-site? Is that cost worth it? Or is it just easier for me to leave the materials there because the cost isn't worth it? And post-construction. Post-construction drones are really useful as well in just giving you quick insights as to what is going on site. So typically once a remediation project is completed, we have devegetated the slope and we need to put in erosion control measures. Well, if you want to keep on measuring how effective your erosion control measures are, you could have a drone pilot go out like once a quarter, fly the area, and using the post-processing imagery software, you can extract the volumes of the slopes and see, okay, we can see that X amount of sediment has actually entered into the watercourse, or we can see that, hey, very little to no sediment has entered. Our erosion control measures are really working here. But if they aren't working, it is also a useful tool to be able to provide either 3D perspective of where your erosion control measures are failing, or even just a 2D perspective where you might be able to see drainage ditches and such forming on the slopes. The other use that you could use it for post-construction is to actually assess the watercourse crossing condition. And this could be, you could be looking at more of a landscape level. Can we see what the effects of our remediation project were on both the downstream and upstream river environments? Can we see that there are going to be problems coming up? You could also do like a seasonal assessment where you go, okay, we can see that our culvert that we installed here is not restricting water flow through the area and therefore increasing the water flow through a culvert and causing a physical barrier for fish during the springtime. You could also use this as just continued monitoring afterwards. So I'll talk quickly about some post-imagery processing, but what there is to say is that essentially there's a range of services available. You have everything from open source free-based software such as OpenDroneMap to Cloud Compare or Envy, where you can actually use with Envy or Pix4D Mapper. It is a subscription-based service, which can either be more integrated with other software products that you use, such as with Envy and the Esri ArcGIS suite, or you can actually start to get services from your subscription-based service providers, such as Pix4D Mapper, where they will do cloud processing for you. So let's say that you have a field operator and he has a field laptop in which he's supposed to be processing all these images. Well, typically these field laptops aren't that powerful. So you could have him instead go back to his hotel at night, upload all of his images to the Pix4D server or cloud, and they will do all the processing for you in a much quicker manner than your field laptop could, and then give you back that information in a lot quicker fashion. So that is some of the advantages that a subscription-based service would have over a free or open source service. And regardless, this is to say that there's a lot of fluvial crossings in Alberta that we have to assess. So I think that ideally in the future, what might be the best way to do inventory for roadway watercourse crossings is that you would actually have a pilot, a drone pilot that has an advanced license or a license that allows him to fly his drone beyond visual line of sight. He has a fixed wing drone and he's able to cover a lot larger area. He's able to go to a site, take off his drone. He covers, let's say, 10 kilometers of area over the course of a day. And then he is able to both do roadway watercourse crossing assessments and also identify potential areas of concern and give you a better idea of what the actual landscape around these roadway watercourse crossings is and how the roadway watercourse crossings might be impacting the river environment or just the aquatic environment around it. So it'll just give you a lot more comprehensive look at what are your actual problem crossings, as opposed to ones that if you're just in the field at a site, you have to assess the crossing and it could not be the cause of the concern. Another crossing upstream might be. So just a brief review of what I talked about today. Essentially with regulation, you need to understand your province's privacy laws before you fly. You need to acquire a pilot's license, either a basic, so basic license is just flying a drone within visual line of sight, or an advanced license, which gets you beyond visual line of sight. You need to register your drone with Transportation Canada. Any commercially used drone has to be registered. And you need to know the airspace that you're going to be flying in so that you're not flying in restricted airspace by accident or getting yourself in trouble. When we talk about flight planning, essentially you got to know your goals and you need to set up your drone flight to reflect those goals before you go out. Drone imagery, I think, for watercourse crossings is at its strongest in the planning stage, in that it allows you to get accurate representation of the conditions, of the site conditions, and allows the precise planning of construction materials needed, what considerations you need to make in terms of utilities, and that type of stuff. When we look at during construction, drones are really useful for relaying site progress to managers who aren't capable of going to site, and of monitoring site conditions, and also giving you up-to-date inventories of your materials that are on site. Post-construction, it is useful for monitoring erosion and erosion control measures, and can be used for monitoring your watercourse crossing conditions as well. And then for post-imagery processing, all there is to say is that price range varies greatly. There's a lot of services available, and it's really up to you, the user, to know what products you use, what could either integrate with the products that you already use for GIS purposes, and so what is going to be the most helpful for you or the best bang for your buck for the services that are provided. So I'd just like to say thank you, and are there any questions?
Great, thank you, Iain. So just before we get into the Q&A period, just to give people a little bit of extra time to get those questions in, I'm just going to put up a quick poll for 30 seconds, just to give us an idea of what everybody's background is from the audience. So I'll just launch that right away. All right, great. Well, thanks for everybody for answering the poll. So it looks like most people are from consulting, which is not surprising given the topic. Yeah, so we'll jump right into these questions now. So Iain, I'll just read those off to you. And then, sure. Yeah. So the first question here is, what would be the best drone type, or a helicopter style versus a fixed wing, for the stream crossing assessment?
Personally, I would think that the helicopter style is the better to use, just because if you need to, you can get lower to the roadway watercourse crossing itself and get oblique images of the watercourse crossing, which can really greatly help with the 3D point cloud processing or creating a 3D model. Whereas with the fixed wing drone, you're kind of stuck with probably the height of the vegetation that's surrounding it, because you don't want your drone to like accidentally get blown into some trees. And seeing as it's a lot more restricted in its horizontal movements, yeah, it's just not as safe, I would say, for the drone itself to use a fixed wing versus a helicopter style. But depending on your environment, if you were to be flying, let's say in the boreal and you're flying across like a big marshland, you know, you're going to cover a lot more ground with your fixed wing drone than a helicopter style drone. So I would say for individual assessments, yeah, helicopter style is going to be the better. But for maybe doing mass assessments, your fixed wing drone is going to get you more crossings in less time.
All right, great, thanks. So the next question here is about ground control points. So are ground control points necessary for non-survey grade assessments?
Yeah, so that's ties back to that goals and objectives, right? And so as you probably saw in a couple of those pictures, where it's just a picture of the site itself, especially for if you're doing like site monitoring, no, ground control points aren't necessary. If you're not trying to get accurate measurements of something, such as like volume estimates, then ground control points aren't necessary, especially if you're just going to be taking a single photo. If you are trying to get ortho imagery for a site, then yes, I would still say ground control points would be good to use. But yeah, for non-survey grade, a ground control point isn't necessary.
All right, great, thanks. So the next question is, what are the typical flight authorizations one would need to get to fly? For example, airspace approvals.
Yeah, so typically nowadays, a lot of the drone software, especially the flight planners, actually have the airspaces themselves uploaded into the imagery. So using the GPS coordinates of the drone, it knows what airspace it is in. So it's up to you to know what the codes are when it comes to airspaces. Typically, especially if you're just flying for natural resource companies, you're not going to need airspace approvals because you're flying in non-restricted airspace. It only really comes into concern when you're flying closer to towns that might have their own airports. Then you need to know what's going on. So it's really only around like heliports or airports or military operations that you got to have any type of permission from, yeah, Transportation Canada or otherwise.
All right, thanks. So this next question is about the video that you play at the beginning of the presentation. So for that presentation, or for that video, sorry, was that created using a point cloud sensor such as LiDAR, or was it made with photography and post-processed into a point cloud? And how much does the processing software cost?
Yeah, so that was done with photography and then post-processed into a point cloud. So that was just using a DJI Phantom 3 with its 4K RGB camera. Yeah, taking, I think, probably like 80% overlap between photos. And yeah, then just post-processed into the point cloud. The processing software cost to purchase. I think Bruce or Javin might be able to answer this a bit better. But I think for like Pix4D, which is the one that we used, it's around like $100 a month if you want to do a subscription service, and that's how it's done. It's subscription based. So.
Yeah, I didn't actually introduce our other panelists. Sorry about that. So we have, I guess we have Bruce with us, Bruce Nielsen from Woodlands North. And we also have Javid Iqbal, who works on contract with Woodlands North, but also works for the GOA. Maybe one of the two of you would be able to give a better answer for the last part of that question, which is how much does the processing software cost?
I can chime in here. It's Javid. So the perpetual license is definitely costing more, and the $100 which Iain mentioned, it's roughly around $300. In fact, monthly cost. It depends on what kind of other extras you have on. So if you are using the Pix4D server, that will cost you more. Now, it depends on your project there. From project to project, you can do 20 projects for the Pix4D mapper license within the same cost of your $300 a month. And usually, if you have more projects in hand, more work, it's better to go for a perpetual license or a monthly subscription. The basic one, or if you have fewer projects, it's better to go for monthly subscription without any server.
Great, thanks for the input, Javed. So how accurate are the photogrammetric triangulation volume calculations to something like LiDAR or manual calculations? So how does it
Yes.
compare to those types of methods?
Yeah, so photogrammetry is never going to be as accurate as LiDAR. LiDAR is still kind of the gold standard when it comes to doing volume calculations. But I would say it's probably going to be around maybe, well, and it also depends on how you set up your flight plan. Like I said before, the degree of overlap that you have between images, the quality of your GPS sensor. So as an RTK, it's going to actually be a lot more comparable with LiDAR than without it, and the number of ground control points that you have, because the more ground control points that you have around a pile, let's say, the more accurate the stitching or registering together of images is going to be. So if you were, just intent on getting a very high resolution volume for a pile or otherwise, I would say that it's probably like within 5 to 10% of the accuracy of LiDAR. Whereas with manual calculations, it's typically a lot better. I would say it's probably around 20% better on average than using manual calculations.
All right, great, thanks. So the next question, what will be the benefit of having oblique imagery in crossing assessment? So the fixed wing flights beyond visual line of sight that you envision for large-scale crossing assessments can be used for the oblique imagery capture. So it's asking, can a fixed wing also be used, or does it require the copter style?
Yeah, it would depend on, once again, the environment, how close, I guess, the trees are surrounding the roadway watercourse crossing. Because even if you say your inlet or outlet side is, covered by trees, having a helicopter style drone is still not going to get you that oblique imagery. So it's very site to site dependent. What I would say with the fixed wing drones is it would be more suitable to open area, open environments, because then you could fly a bit further out and get oblique imagery still of that road. Whereas if you're flying in more closed environments, you're going to, and you still want to get the oblique imagery to get a really good 3D point cloud of that watercourse crossing, the helicopter is the only way that you would be able to do it with a drone. Hope that answers your question.
I think that does, so thanks for that. Can an individual fly these on their own to collect data, or when is a co-pilot needed?
Yeah, a co-pilot is needed when you go beyond visual line of sight. Co-pilot you should have as well, especially if you're doing like manual flights of drones, because if you are doing a manual flight of a drone, you're going to be concentrated on the screen and seeing what the drone sees. And you need to have somebody with you to actually be looking at the drone itself so that they have an idea of where it is. And this is just, it's a safety concern, especially if there are other aircraft in the area, such as like helicopters. You need to know where they are and where your drone is in relation to it. So that's when you would need a co-pilot. If you are using the flight planner software, typically you can be an individual pilot yourself, because you are also, you're not really concentrating too much on the actual controller itself, because the controller is just telling you where in the flight plan your drone is, and you would be able to just keep your eye on the drone in the sky, and therefore you are the spotter and the pilot itself. But like I said, it's pretty much on autopilot anyways. So you just have to be aware of where it is in relation to any other aerial objects or trees and such.
All right, thanks. So the next question, I guess just to let our attendees here know, I draw the line at the 1 hour mark, so at 2 p.m. It's now 1:51, so we have about, excuse me, sorry about that. So we have about 9 more minutes. Just to let anybody know, if you do have questions, please submit them. If we don't have time to get to them today, a transcript of the Q&A portion will be distributed later on. So if we don't have time to get to those questions during the Q&A period, we will distribute the answers at a later date. So this next question here, where did you get the 150,000 fluvial crossings from? Are these for dispositions in Alberta?
Yeah, so this is just using the DIDS layer that you can acquire from Altalus. Using the DIDS layer, using Alberta transportation layers for all the roads and highways, and using a hydrological model that we developed ourselves in-house to predict streams. So it's using, an in-house stream model, essentially, and just using intersections between the DIDS plus layer, those crossings, and then also crossings that have to do with Alberta transportation, so highways, public roads, that type of thing.
Great, thanks, Iain. So this next question is about the cost of making one of these 3D models. So I think that's a bit of a complicated question to answer, and we don't really want to get into the services that we offer as a company from Woodlands North. So John, maybe we'll reach out to you afterwards to give an exact quote of how much we would be able to do that for. But I guess it would vary quite a bit from service provider to make one of those 3D models.
Yeah.
But if you do have any more questions, sorry.
Yeah, and it might be best, if you are interested, to reach out to Bruce Nielsen, one of the panelists here, who would be able to give you that.
Yeah, or just since Ian's email is provided in the presentation, you can send an email to Iain and we'll arrange that for you. There's another question here. We are kind of running out of questions, so this may be the last one we get to. So this one is, have you received approval for any beyond line of sight flights for this application? My understanding is that these approvals are still fairly rare in Canada.
I personally do not have a beyond an advanced drone license, so I have never attempted a beyond line of sight flight myself. So I can't really speak to that. I do understand that, yes, you have to submit the flight plans to Transportation Canada so that they are aware that you are doing a beyond line of sight flight. But yeah, I haven't gone to the application process myself, so I can't say too much to that.
All right, thanks, Iain. Yeah, so we'll just wrap things up. We're about 5 minutes from the cutoff, but yeah, we'll wrap things up. So I'd like to thank today's presenter, Iain Sharp. Thank you to everyone who attended the webinar, and we hope that you'll join us for some of our other presentations over the next few weeks. Our next webinar in this series will be taking place next Tuesday, May 12th, where we'll be having Mark Posch presenting about measuring fish habitat connectivity in freshwater ecosystems. So if you enjoyed this webinar, I encourage you to look at all the other webinars scheduled as part of our series on our GoToWebinar page or on the AWC3 website, which is awccc.ca. So thank you again, Iain, for presenting to us today, and I hope to see all of you attending some of our future webinars. So stay safe and have a great day.